Hello, I'm David Skinner and I wanted to share some work we've done this year benchmarking our software architecture. This is a new task for us and it was kind of important to see how fast our architecture was working. This presentation details what we've done, how far we've got and what we want to do next. So the things I'm going to cover are the context of all of this, why we want to benchmark and how we do the benchmarking. I also want to cover a bit about Dialects, which is an obstacle we had to overcome. Look at the results I got comparing MC3020 to MC-Ada. Look a bit more deeply at one of the tests and then wrap up with some conclusions. So the context of this is some people have a perception, and it may or may not be true, that generated code is slow, that it's bloated, and also we would like to know how good our particular code generator is against other model compilers, and this might be useful for new people. So what are the relative strengths of one model compiler over another one, and how does one model compiler, say A, compare to model compiler B? And if you do choose a model compiler, you really need to know what's good and bad about it. So it would be kind of nice if we could find out what are the good and bad points about each different model compiler. So why benchmark? Well, we really need some objective data, and it doesn't seem like a particularly difficult thing to do, especially with the model which we found on GitHub, which is kind of set up to do it already. We also need to ensure requirements can be met. So if we do have an application that, say, counts 10,000 things, we need to know that that's going to run in a reasonably quick way, especially if we've got sort of hard time constraints to meet. And relative comparisons are useful. So if you were in a privileged position of having a choice between code generators, you could make an informed choice about which one is going to meet your requirements. And the next two slides are going to detail what I want to measure and how do I want to measure it. So the what, for us predominantly it was speed, but we also have an interest in resource consumption, memory consumption, things like that. And we want to really measure all the key Shlaer-Mellor constructs we use in our models, so there is a list of those in there. So when you're looking to measure a Shlaer-Mellor construct, you really need to avoid the observer effect. So you really only want to measure what you're actually testing. And you need to loop it up and repeat it. So these things run quickly, so you need to do it lots of times. And as I said, only measure the operation under test. So we turn off the clock while initializing, cleaning up and reporting. And we also need to plan how long you want the test to last. There's probably pros and cons to a quick test and a longer test. So you probably want to make that optional. And you really need a key state model to drive the tests. And we were fortunate in that we found one of these in the bench model on GitHub. And that brings me nicely to the subject of Dialects. When we found the original bench model in GitHub, it wasn't a dialect that wasn't compatible with the Ada model compiler. So as well as changing the action language, we also had to rewrite the model to split it into two domains and a deployment. This demonstrates that we should allow sort of different dialects to inform each other, and we should maybe try and write our models to a common dialect if possible. And in fact, this has started to happen because I know that Court is now building some of his OAL domain components in the sort of Mazel ASL style, so that we allow the greatest possible way that different model compilers can work on the same model. So this is the model, this key state machine in the bench model that we obtained from the model on GitHub. I think this is a really neat state machine, and I'll try and explain how it works. So the first state really just sets everything up for the test, and then we go into the state 2, which is the run state, and we run the test. And this is a state that's timed. So all the time we're in this state, we're doing timing. And when we've done what we have to do, then we go into state 3, the clock is now stopped, and we see if there's any more time to do more testing. So say for one test we'd allocated 1 second, if we've been in state 2 for maybe a tenth of a second, we'd have time to go back and do it again. And we continued like that until we had expired the whole test period. So for instance, if we were testing over a second, and then we would go into the cleanup state at the end, and that would be the state machine run for one test. And then we have a number of tests which you'll see the results in a minute, so you would repeat that for other tests. And the results are coming on the next slide, and I apologise in advance for the quality when I uploaded this for the presentation. So these are the results we got pretty much out of the box. This is, remember, an unintelligent translation of the original map bench model written in OAL to a similar model written in ASL, but no attempt to be made to look at whether the test was sensible or anything else. So what you can see from this is generally you can see that MC3020 is faster than our ADA code generator. Some constructs are a lot faster than others, so you can see the scale. I mean, you don't really get much information about some of the tests. And some of these tests, actually, when you look at them, are very trivial. The top few are very much just procedure calls in a lot of cases. So didn't really give us a lot to go on here, apart from the overall conception that our code generator was certainly slower. So what we needed to do next was to have a better look at the tests which were really the things of interest, of the real Shlaer-Mellor constructs like finds and cardinality and event generation and deleting classes. So that's what I'm going to look at one instance of in the next slide. So in the results I've just presented, there were 4 tests for cardinality. Cardinality is counting instances of a class. The ASL people amongst you would know this as a count of operation, but in OAL it's cardinality. So I've just shown you an example, couple of lines that are contained in the part of the test that we are timing. So you can see in OAL there's a select many from instance A, and then you do the cardinality line to do the count. In ASL you find the set and you do a count of. Now I think myself that perhaps we should only be doing the second of these 2 lines in the test, but that is how it is at the moment, but it's still, the results, as you'll see, still show us something useful. So I'll move on to results. So these are the results, and I think you'd agree that these do show something very useful. So you'll see the first test is a test of counting 10 instances, and then followed by 100 instances, followed by 1,000, followed by 10,000. So you can see that MC3020 counts 10 instances pretty quickly, but then gets progressively worse. 100 instances, it's quite slow. A minute, it's really, really slow for 10,000. Whereas the ADA software architecture is pretty much consistent, really. It just takes the same amount of time to count however many instances there are in your set. So the reason for that is quite simple and obvious when you have a look, and that is on the next slide. So if we look down into the software architecture and how it does the count of the instances, we can see that MC3020 has an implementation where we set our node to the head of the class list, and we actually walk through the list. So there's a while loop and you add 1 to result, and when you get to the end of the list, what is in result is the number of instances. The ADA implementation is good in this respect because we have maintained a count all the way through whenever we are adding and deleting instances of a class. So really simple, you just return the attribute. However, obviously there is a maintenance element to this, so there'd probably be worse performance on the creation and deleting of instances, but we haven't really analysed that yet. It's just an example of a difference. So to wrap things up, I think what I can say is I think this has been a promising start. I think the model we found was good. It was a really good starting point. We are only a little way through this journey. We need to do some more assessment of our tests. I think some of the tests do mix some constructs, so we need to look at that. Maybe remove some of the simpler tests that aren't really telling us much about our architecture. And then the model, I think at the moment everything is hard coded and the test duration and everything like that. So we need to really have a look at that and see if maybe running the test for longer would give us better results. So and the main thing really is to work through these tests, test by test, and also see if there's any tests missing. So that's it. I will go on to the next slide for questions, and thank you for listening.